Hey everybody, this is Larry. This is me doing extra algo prom that I haven't done yet. And I've been kind of doing them in reverse order because these are the new proms, so maybe it's a little bit, I don't know. I don't know if people prefer RNG, but I don't know. Today is fine. Anyway, let me know in the comments what you think, though, how you think it should be. Hope everyone's having a good weekend so far, and today we have this prom. 3125, maximum number that makes result of bitwise n 0. Given an integer n, return the maximum integer x such that x is less than n, and the bitwise n of all numbers in the range x to the n is 0. Return the maximum number x such that x is less than n, and the bitwise 4. Oh, wait, what? Number x. Why is this 3? Oh, because it's... Okay. So, and yeah, one thing that I took a peek at just to constrain, so that means that obviously you can do brute force. But yeah, so the idea here, I think it's just taking advantage of bitwise n, and then and then just try to get the next number that you can, right? So for example, with n is equal to 7, the thing that I would play around with is 7 is this, right? So then now to get the next number that is a 0 in here, it's going to be 1, 0. And then the next number that is a 0 here is, I think, this number, right? And then the next number that is a 0 in the first digit is going to be 1, 1. And this is going to be 3. And that would be our answer. I'm also trying to, I mean, in this case, it is the number with the significant bit, but that's because we go through all the other possibilities, right? So I'm trying to think whether that's always the case, and I don't think so. Well, is it? For example, if you have like something like this, is it good enough that this? Well, actually, it would be this, right? Is this good enough? Is this always implied? Like, is the answer always going to be a power of 2 minus 1? Because I think so. I mean, I wanted to, or like, that's my intuition, that's my gut. I can't really prove it yet. But the idea here is that going from here 1 to 0 means that all the intermediate values will also go from 1 to 0 in a subtracting kind of way. And there's really no way around it, right? Because if this is a 0, then, well, you're already done with that bit. If this is a 1, then by definition, these are all going to be, how do you say it? Like, these digits will flip to 0 before this digit, no matter what. That's just how it works. So I think that makes sense. So that means that, yeah, we just have to get the max bit, and that's it, right? So here, maybe we can do something like, I don't know, I'm just writing this in a lazy way. So 10 to the 15 is what? I don't know, 60. It's less than 60, I know. But then you have just like, if the shift bit and this is greater than 0, right? Or maybe we could just count backwards, right? And then we just see the first one that we see, and this is the first one, then just return 1 to the power of I minus 1, and that's it, right? Yeah, and you can probably even play around with big numbers. I don't know, I mean, just to kind of play around with it. Yeah, it looks okay, so let's give it a submit. And yeah, I don't know why this is so slow compared to everyone else's, but it's fine. I mean, actually, I don't know. But it's fine. Or I mean, I think the other way that you can do about it is that maybe bits is. I guess this is. I don't know why I kind of was a little bit lazy on this one, right? But something like this, right? Maybe that'll be fine. It's either that I'm off by 1. I am off by 1, but that's fine. Right? Is 0 the input or possible input? I don't know if this is quite right, but it should be mostly right. I mean, I guess this is faster in that way. But I don't know. It doesn't really matter. I mean, because the other one is kind of n square-ish, if you want to call it that. Not this n, but the input number of input bits. But and you could of course use like a string function. There's a lot of ways to do this, right? Just counting the number of bits. So you could probably you don't even need the shift thing. You can just do like a log2 thing, though sometimes it's slower. But yeah, anyway, I mean, you can play around with the timing. I don't care enough. This is going to be linear time, linear space, keeping in mind that linear is in the size of the input. And the size of the input for this problem is the number of bits. We do, the while loop will do one operation for the number of bits. And this is obviously just the number of bits. So yeah, so linear time, linear space. That's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. Yeah, I'll see you later and take care. Let me take a look at the hint. What hint can you look at? Yeah, okay. I was just curious what hint can be. But yeah, I'll see y'all later and take care. Bye bye.